It's a full moon. Is there a full moon? We need to know why all these problems are happening.
It's the election.
That's right. This is just they're trying to say for me. Okay, here we go. Thank you. Let me get us started. Sorry. I got to look ridiculous. Okay, this is going to be fun. If we ever get it started. Let's try. We have Howard Bloom here today. I've known Howard for a long time, and just a great guy. What else should I say?
Maybe I better stop while I'm ahead.
That's right. There are basically 3 levels of expertise in doing field experiments. There's the novice, a journeyman, let's put it that way. There's the expert, and then there's the Bloom. Okay? We have a Bloom, and in particular, there are actually 2 Blooms. The Sue Bloom, the other Bloom, was not able to be here. I guess you saw my note on that, but we do have Howard, and that's almost as good. Howard did PhD in, political economy and government at Harvard, taught at Harvard for 8 years, taught at NYU for 13 years, and actually was an award-winning faculty member at both places. He's been at MDRC, which, for those of you that don't know the contract world, that is the Harvard of the contract world, since 1999, serving as chief social scientist. And if you go to the MDRC website, you see the president of MDRC, the president, vice president, and then Howard. So he's like right there on the front page. Number 3 guy, soon to be number 1 because of the Bloom status. Howard's been at this a long time. He's been doing experiments for many years before it became fashionable, and has written a number of books, papers, chapters, monographs reporting on the results of some of the largest field experiments that have been done in the last decade. National Job Training Partnership Act evaluation, 16 sites, 21,000 participants. It's co-PI on that. Another example is the displaced workers. And now he's going to be talking today about a very important, for education purposes, a very important policy area, which is Reading First, which has lots of people anxious about the whole status of evidence-based practice, because this is one of the first instances that was reported as an example of that. Let me just say one more thing, 2 more things. In addition to telling us about what works, for whom, and under what circumstances, in a substantive way, Howard has some of the best technical discussions of issues of how to optimize randomized trials in the field. He's taken what he's learned in trying to answer these big policy questions, turned that around and said, how can I help to make this a better field, that is, experimentation, by essentially doing a lot of work on ways of analyzing cluster randomized designs where noncompliance is present, methods for optimizing cluster randomized designs with the inclusion of covariates, use of propensity scores for evaluations in that are quasi-experimental, and the use of regression discontinuity, which is what he's going to be talking about today. I can probably stand here and talk the rest of the time, and then you won't get to say anything, and nobody will see how pretty you look. It's beautiful.
I can do that.
Why don't you take over, Howard? I'm really delighted to have Howard Bloom here today.
This is a personal first for me with this uniform on. I'm very pleased to be here. I also spent a lot of my time working with Mark. Mark and I, the last couple of years, have been working on a project on effect size. It's been one of the most gratifying projects I've ever worked on. So I know both of you guys, and I've enjoyed the association over the years. What I want to talk about is our work. We're doing, MDRC is doing this with Apt Associates Incorporated, which is a Cambridge, Massachusetts, and Washington, D.C. based research group. We're doing the national impact study of Reading First. And I'm going to do it as a story with some analytical stuff in the mix and talk about kind of what we're doing, why we're doing it this way, what we started out trying to do, how it evolved, and then also get into some of the analytics of regression discontinuity. What I can't tell you anything about are any findings. There aren't any findings. If there were and I told you what the findings were, I'd have to kill you, and that would be inconvenient. So that's not what we are. We're really, this is both methodological, logistical, about research on the ground at a large scale for a very, very policy-relevant program. This is the most politically sensitive job I've ever worked on. This is the president's. This is No Child Left Behind. This is the reading component of No Child Left Behind. The stakes are enormous. The pressures on the funders, the U.S. Department of Education, are incredible. And it's just really a very, very unusual situation. And the analytics are fascinating. So, and they all come together in some really interesting ways. So I'll try to talk about pieces of all. How long do I have? Mark knows me. Okay, you guys could be here going into Sunday if I'm not restrained. What are we talking about? All right. So let's start. About this topic. Okay, well, I already did that. Well, no, let's be systematic. I want to introduce the key elements of regression discontinuity. How many of you know anything about regression discontinuity analysis? All right. Well, I didn't either about a year and a half ago, but I always wanted to, and so this is my opportunity to learn about it. So we'll talk about some of the key elements of regression discontinuity, design and analysis. We'll talk about reading first impact study, just to give you a sense of the context in which this is playing out. And we'll talk about the conditions that are necessary for a regression discontinuity design to produce internally valid impact estimates. Okay, they're very important conditions, which aren't necessarily always met, but sometimes they are. And then consider the conditions affecting external validity. There's some particular issues around regression discontinuity and how you do it, and the external validity of it, which I think will become apparent as we talk. So that's kind of what I want to focus on. About the study. Okay, the study was mandated by Congress. It is the national impact study of the national program for reading. It's funded by the Institute of Education Sciences. That's the research part of the U.S. Department of Education. Many of you are very grateful to IES. I know David is. I know Mark is. I know some of your doctoral students are. And as I said before, the study is being conducted jointly between Abt Associates, MDRC, Westat, and others. One of the things you will find is these studies are really, these big studies oftentimes are not done by one organization. Oftentimes they're done by consortia of organizations because they are so big. And we're talking about $25, $30, $35 million for one study. Okay, and there's lots of moving parts, and there are hundreds and hundreds of people. The data collection, a lot of primary data collection, and everything else. So they're massive enterprises. Okay, so oftentimes there isn't enough availability of staff at any one of these places, and they're all good places. And so you kind of team up. And sometimes, it's Abt and MDRC competing against Mathematica and somebody else, and sometimes it's MDRC and Mathematica competing against Abt, and then there's AI. And so the organizations mix and match, and it's actually, I think, gotten more that way in the last 20 or 30 years than it used to be, which I think is a good thing, that there's more of this cross-walking around across these organizations, which I think is a really good thing, because I know people at all these places. I've worked with people at all these places, and that creates a different relationship about learning stuff. I can get on, Mark and I were having a little discussion about something, and I got on an email to people in all these firms about what they were doing, and within hours, right, we got back feedback from the most senior people at these organizations who know how this issue is playing out in this environment. And, if we didn't have goodwill amongst us, that just wouldn't happen. I would have never written that email in the first place. So I think there's some nice things happening out there, sort of organization. All right. And what we're trying to do, though, is we're trying to provide rigorous impact estimates of reading first. And I'll say on what in a moment. In a purposive site, not a nationally representative sample of sites. I can tell you lots of reasons why that's not the case. But purposive but diverse site. Oftentimes that's the most you can aspire to in terms of the internal, rather the external validity of the structure of your study. So you don't want to just do it in New York, because nobody except New Yorkers care about what happens in New York. You don't want to just do it in Peoria, but you probably better get there, and so on and so forth. You want diverse geography, demography, et cetera, as best you can, given other constraints. So that's what we purport to do, a purposive but diverse sample of sites to be as generalizable as possible, but in no way purporting to be a nationally representative sample, because that simply was not even close to possible for such a study. All right. So now about the program, very quickly. How many of you know something about Reading First? All right, so I'll do this really fast. So Reading First is the reading part of No Child Left Behind. It's funded at the level of about $1 billion a year. It's supposed to be based on scientifically validated approaches to teaching reading, and there's now a lawsuit and an inspector general study all around how that was or wasn't done properly, and so on and so forth. And it's K through 3 is the focus of the funding and the focus of the program, and its primary goal is basically to get kids by grade 3 to be reading at grade level. Do whatever it takes between K and 3 to make that happen. Now the funding process, which is really, really important here, and which ultimately gets at why the study is being done the way it is as follows. The federal government put out, Congress passed a law, and then they put certain constraints on it, and then the federal government, the Department of Education, funds state proposals. Each state had a proposal for Reading First, and how they were going to run it, and what they were going to do, and where it was going to take place, and how they chose where it was going to take place, et cetera, et cetera, et cetera. So the states didn't get their money automatically. They only got their money when their proposals were deemed worthy of funding. The money was allocated. The money was there for all states, but it wasn't a direct pass-through to the states. The states had to do whatever they had to do. This is actually part of the lawsuit in terms of how the states were influenced in doing what they did, and more importantly, what they didn't do, so on and so forth. But so the states get their money, and they distribute it to the school districts. And the school districts distribute it to a subset of their schools. Reading First is supposed to be very purposefully funded. It's supposed to be to those schools that need it the most, and those schools that want it the most, and those schools that can do the most with it. That becomes incredibly important when I talk to you about the design of the study. Okay, incredibly important. All right, so that's some background. Now, mind you, I don't know much about Reading First. I don't know much about reading. I don't know much about education. And I'm one of the methodologists on this team, but I work with people who know all these things, and they know how it works in the field. That's another thing about working in these organizations. In talking to David and Mark, I think part of what would be interesting maybe for me to talk about is how these things really happen. Okay, you have people on the team that have been teachers, been superintendents, been this, that, and the other thing. You have people that could go sell the sites and get them to do things that they wouldn't normally have done, or get them to do things that they never thought they would do in a million years, and stuff like that. So you have a wide range of expertise on these teams. Okay, and it's really important to have that kind of expertise. And you also have to have on these teams, though, a sense that the research is what it's all about, and that if it compromises the research, it's not worth doing. So even though you've got operations people that really know, but the research people, the flip side of that, has to know if it can't happen in the real world, we're not researching real things, then that's pointless. But the other part of it is if we can't research it, that's pointless too. And so you have to have this dynamic in the team between the operations people, the research people, and so on and so forth, about, we're trying to learn something about what really happens in the world, but in a very rigorous way. And that's really hard to do. All those things together all at once. It requires a lot of expertise. All right, so the evaluation design. What we're interested in is the impacts on reading instruction, the type of instruction, quality of instruction, in grades K through 3. We're interested in the impacts on reading achievement. That's the ultimate bottom line, as measured by, unfortunately, tests of reading achievement. And at various points in time, we're more or less interested in the relationship between instruction and achievement. And I could talk for an hour on just how the waxing and waning of that part of the study has come over time and the forces at play to make it happen. It's really fascinating, but that's slightly beside the point. But it really is pretty interesting. In other words, how does instruction affect achievement? How would you study that, and so on and so forth? Now, the first two we started out trying to do experimentally. The last one was always going to be a non-experimental correlational analysis, so on and so forth. But the original study design, okay, here's what we're going to do. Well, first of all, the way this thing evolved over time is the Department of Education wanted to do this, and I don't know the insides of this, but there's the research part of the Department of Education, then there's the program part of the Department of Education. The problematic thing is they never talk to each other. They kind of hate each other, all right? So that was a problem, and they really did probably still do hate each other. That's a problem. But So you got the programmatic part, the ones who are responsible for all this money and all these programs and everything else, having to deal with the research part, who's responsible for the congressionally mandated evaluation of this thing, trying to come together to do a study that's acceptable to all parties. And originally, IES wanted to do an experiment, and this is probably the biggest study they fund. I don't know that for a fact, but I would guess it probably is. And certainly one of the first big studies that they funded. And it was supposed to be a randomized experiment. It was going to be a cluster randomized experiment. What it was designed to do was randomize schools into reading first or not, based on some basis. The schools would be picked. In about 6 to 10 districts, because we weren't just going into one district, for generalizability, we wanted to be in a few districts. Half of the program, half to control. That was the original design. And I actually wrote the design paper that the department used, trying to figure out how many schools and so on and so forth. Because one of the things I've gotten interested in is cluster random assignment, and what kind of sample size, and how does that change statistical precision and all those kinds of things. So there was at least a year or so when the department was trying to figure out how to do this experiment. And, I wrote this paper and we had conversations. And then they went out with a request for proposals, an RFP, to actually do this evaluation. So the little paper that I wrote was before the big request for proposals came out, just to give you an idea of how this evolved over time. And so they put out an RFP, and that's how the various consortia formed around the writing of the proposal to that RFP. And we turned out to be a particular consortium. We turned out to win that particular thing. And then we turned out to have to try to do that. All right? Now, it very quickly became clear that was impossible. And the irony of this is beyond delicious. It's really, and it's painful and everything else. Here it is, IES, pushing randomized experiments. And the biggest, and one of the first projects they have, hits a wall because, and it's pretty clear why, many states and districts were already funded. It was too late. The train had already left the station. You can't go back and randomize the money away. That's not possible. All right? So, a lot of states, not just a few. And those states that hadn't done it yet, the whole ethic, the whole gestalt of reading first is purposive, not random. And in lots of important ways. All the regulations were written in certain ways that you would pick schools purposely, pick them in accord with need, as measured by poverty status, poor performance of the student staff. Over and over and over again in all the documents at the federal level and at the state level and at the district level, all the conversation was about targeting. Now that's about as antithetical to randomization as possible, unless you could kind of randomize right on the margin or something like that, which we were hoping to do. Okay, but because we'd already missed so many states and districts, and because there was just so much of this purposive right in every aspect of the program, it just wasn't going to happen. Now, at a certain point this became really clear. And so Russ Whitehurst, who I know he visited you recently, and Pete Cunningham and Ricky Takai and his staff, we all got together and said, well, what are we going to do? And what are we going to do, real fast, immediately? What are we going to do? And so we kind of had to reassess what we were doing. And we sort of went through the litany, or the list of the possible alternatives. Well, we can't do this randomized design. Maybe we could do interrupted time series design. I've been particularly interested in this kind of stuff over time, and whole school reforms and stuff like this. But usually there are a lot of problems with the data on those things, and to really count on a national study. I wasn't real keen. None of us were real keen on that. Non-experimental comparison schools, nobody liked that. That's exactly what IES was trying to stop being done. And everything propensity score, that didn't solve that problem either, and all this kind of stuff. And so there was this regression discontinuity analysis, which, as I was saying before, I'd always wanted to do one. I didn't quite expect to do one like this, but I'd always wanted to do one. And so we very quickly, read about this stuff and thought about this stuff. And these are team meetings, across inside of MDRC, and there's some very good people at Apt Associates that we're working with. Very, very intense. And we figured out, we could do this maybe under certain conditions. Now, let me describe, and then, so at a certain point, we wrote a little position paper that said, we think we can do it if we can find the following districts, if we can find districts that did the following. And if we can find enough districts with enough schools to give us the sample, to give us the precision that we need for the work. Okay? So we had a meeting about that kind of stuff. And so here's what we end up with, and then I'll really describe what we're doing. What we ended up with is not one regression discontinuity study, but 17 regression discontinuity studies, one in each site. A site is either a school district or a whole state in one case. And one cluster randomized site, which allowed us to do cluster randomization. So we have 18 sites, most of which, 17 of those are school districts, one a state. We did regression discontinuity, which I'm going to describe, in 17 of those, but it's a separate one because each one rolled out in different ways, which I will describe, and randomization in one. And we end up with 200, instead of 60 schools, we end up with 250 schools. And I'll describe to you exactly why that is the case. But the statistical power considerations are such that under a wide range of circumstances, you need about 4 times as many schools for regression discontinuity design, which I'll show you why, as you would if you'd randomized. Okay, that comes under there is no free lunch. There was a very high cost to shifting gears here, but it was still doable. All right. Now and half the schools are in our treatment group, and half the schools in our comparison group. So we have a balanced design in that particular regard. Now, let me describe how this thing works. Here's what we did. We said if we can find enough. Regression discontinuity design is the following. It was dreamed up by Don Campbell in the 60s. Okay, with another guy whose name is totally not pronounceable. Say it fast. But there's another W in there. It's Fifthwaite. There's another W in there. That's the hard part, is that second W. But anyway, these two guys dreamed this up around the National Merit Scholarships in the 60s. It was a way to analyze the impact of the National Merit Scholarships. And they said, we have these criteria that we use to rank and rate the contenders. And then we draw a line, a cut point, and above that cut point you're in, and below that cut point you're out, more or less. Maybe we could do something with that design. And so it's a really creative idea because the beauty, the nicest part of that design is, what if you had lots and lots of thousands and thousands of applicants, and you arrayed them on some criterion, and then you went right to the cut point, and there were still hundreds and hundreds of applicants right at the cut point, right? And you picked those that were just above, the several hundred that were just above, and the several hundred were just below. What did you just create? What design did you just create? A randomized experiment at the margin. Because what's the difference between those people who were just barely above and just barely below? Noise. Measurement error. Okay, so the idea is really beautiful. And there's been some lots of nice work on it. A guy by the name of Brian Jacobs, who's he's a real rising star in education research. He's at Kennedy School, and now he's at Michigan, waiting here. But he gets tenure at Kennedy School. But he and others did beautiful work in Chicago, for example, where they were interested in social promotions, and they were eliminating social promotions, and you had to pass a test in order to be promoted. In Chicago, a lot of kids there. And they had this test that you could take, and then there was a point below which you didn't pass the test. You had to go to summer school and do this or that, or you weren't promoted. And basically there were tens of thousands of kids that were tested and in any given grade, right? And they were able to go right to that cut point and find hundreds, if not thousands of kids on either side of that cut point, follow up those two groups and see what happened to them the year after that, and the year after that, and the year after that. Okay, so it's a functional equivalent of a randomized experiment. That's one version of it. Okay, that's the one about which I think it would be that's the one that would be least controversial, because it's kind of obvious that basically the only thing that's going on there, for all intents and purposes, that distinguishes one group from the other at the margin is noise. Okay, so that one's really comforting if you could do that. The other version of it, you could call that a tie-breaking experiment. Kind of. The other version of it, which is where regression discontinuity comes in, and I'm going to show you a graph in a minute, but for example, if the computer really weren't working and my pictures weren't up there, you might start off with the relationship between the outcome. Well, let me go forward to it. There. Okay. Let's say you had a whole bunch of schools, and they were ranked or rated according to some criteria. Now, one of the nice things is they could be ranked or rated on anything. It doesn't matter. It could be subjective assessments. I'm giving that one a 5. I'm giving that one a 4.5. I'm giving that one a 3. It could be objective assessments, percentage of kids on school lunch, or percentage of kids scoring non-proficient. It could be a combination, a composite of qualitative assessments and quantitative assessments somehow mushed together. It doesn't matter. But as long as there's an assessment, call that the rating, okay, then whatever, and then here's the outcome, some outcome measure, future outcome, future performance of the kids in those schools, let's say. Okay, whatever relation, and these are the non-reading first schools, let's say, and this was the cut point. And this, the horizontal axis is the rating. So you're going, let's say this one is from lowest percent proficient in the past. Are you with me? To lowest percent free lunch. Lowest percent free lunch in the past to highest percent free lunch in the past. Okay? And what literature shows over and over and over again is poverty status is negatively related to students' performance. And so what you see is you see a relationship, some kind of relationship between performance and the rating. And the idea, that's the regression part of regression discontinuity. And there'd be a regression line on one side and a regression line on the other side of the cut point. And then the discontinuity part is to the extent that there was an impact, to the extent that this intervention caused something to happen that wouldn't have happened otherwise, you'd expect to see this systematic relationship displaced. You'd expect to see a discontinuity. And it's that discontinuity that identifies the impact. So it's a really cool idea. Okay, it makes a lot of sense. When it works right, you can graph it. So there's a graphical presentation, so you can present it to a wide range of audiences and stuff like that. It rings true with your analytic sense of, gee, I'd really like to break the relationship between selection into these groups and anything it is that was about them before. Well, what this does is it uses this regression line to do that. Now, we'll talk about complexities. There's no free lunch on many, many, many different levels here. But that's the basic idea. Now, let me show you how it plays out inside the design. These are illustrations. I keep forgetting to take the names of the sites on. Of how the ratings were, what the ratings were in some of the sites that ended up in site. Because what we did is we had this, and now I've described to you what the basic idea of regression discontinuity. Now let me talk about the conditions. The conditions in order for a regression discontinuity design to estimate internally valid, to provide internally valid estimates of impacts are the following. First of all, there has to be some continuous relationship between the outcome and the rating. Okay, absent an intervention, absent a discontinuity. Second of all, there has to be a cut point along the rating, which is determined independently of knowledge about what schools got what ratings. So that you can't play games with it. You can't game it and say, ooh, this school here, I really wanted it in, I'll change the cut point. The cut point needs to be determined independently of the values of the ratings for specific schools. Okay? If that is the case, then you have the beginnings of a valid regression discontinuity. Do people understand what I just said, what that condition is? Do you understand why it would be problematic if people were gaming it? Because then there might be unobserved things about why somebody changed the cut points so that school could get in, or changed the cut points so that school would go out, and so on and so forth. As long as the cut point, say it's determined by the budget, say you know that they're going to spend $200,000 on every school in this district, and they have $1 million. That means they can only serve 5 schools. That's how that cut point would be. And they're going to go from the top of the list on down in some sense, right? They're going to do 5 schools, and they're going to stop after that 5th school. If that's determined independently of the actual ratings of the schools, okay, then you have the basis for a valid regression discontinuity design. And what happens is each of these school districts, and in one case a whole state, did their own ratings and their own rankings of their schools. And they used different criteria. So in some cases it really was percent poverty. In other cases it really was percent scoring not proficient. In some cases, it was the sum of those two numbers. Yes?
You made a point they were assessing the quality of their applications as well, which is a very different proposition.
In one case, the whole state had some review panels assess the qualities of applications on some index, which is that's like a subjective kind of thing. I mean, I don't know how subjective and how objective that was. It's a completely different way of doing it. So all of these places they had rankings and ratings, for sure. And as best as we can tell, we did some field work, and the cut points were determined independently of the values of the ranking and ratings. With percent proficient and stuff like that, that stuff is on the record. We went back and confirmed, for example, that the numbers they used were the same numbers we could get off their websites and stuff like that in some cases. So what we did actually is we went looking around the country in a hurry to find places that had made their decisions this way. That's what we did. Once we figured out what we had to do, then we had to figure out how many places did this, and how many schools were involved, and could we generate a sample big enough and diverse enough to be useful for this study. Okay? But an important point is that every place did it differently, and that's why we have 17 separate regression discontinuity designs. Each one, in a sense, is going to be analyzed separately, not really, but more or less. And then we have that 18th one, which is a randomized study. And then we're going to pool the results. Does that make sense? So these are just examples, okay, of the actual values of the ratings for whatever reasons they were given of the schools at different places. You can see Little Rock, Arkansas, Brevard County, Florida, blah, blah, blah. That's just some of them. Okay? And what we did, also, when we had people in the field, what's going on is we're back in the office and others of us are out in the field, or they're on websites and they're saying, we got this district, it has these characteristics, what do you think? And part of the what do you think was we're looking at the distributions, and we're trying to see if they are reasonably continuous distributions. They don't have big gaps in them already around the cut point, where, if you had a big gap in the scores, a really big gap, it's kind of hard to tell whether you should assume things are continuous. But if the numbers are all stacked together, you can fit a functional form through it pretty well. And so we're looking at these numbers, and you imagine there's a bunch of different criteria that we're trying to figure out. Yes, let's do that site. No, that site doesn't work, and so on and so forth. And for most of these sites, there's a fairly high density of values fairly closely packed around the cut point. Not for all of them, but for most of them. So we were feeling pretty good about that aspect of it. But do you see the idea? And this is the design phase. This is the design and the recruitment, if you will, and back and forth between design and recruitment in terms of can we take these sites, and it depends on how many sites we already had and how big they were and how diverse they were and everything else. Does it make sense? All right. So that's what we're working with. So, this is just a picture of the cut point for each site. We just lined up each site that way. So here's all the schools that were ranked and rated in Little Rock, Arkansas. Here's another aspect of it. Here's the cut point. Now, another thing we did from the beginning is we said, look, what we'd like to do is get as close to the cut point as possible. Because what we'd like to do, ideally, we'd like to have a tie-breaking experiment. If we could find zillions of schools right around the cut point, we feel much better. Much, much, much better. So we tried to pack our design as close to the cut point as possible and still get enough schools. Now, I'll show you why in a little while. The formula tells you why you need 4 times as many schools. We knew pretty early on that we had to go from 60 schools to 4 times as many schools. So this green area is the actual sample in those sites. You can see half above and half below the cut point from amongst the larger group of schools that were ranked and rated, that were in contention. Now, that's not all the schools in the sites. That's just all the schools that were in contention for reading first in those sites. Does that make sense? Does it make sense why we want to pack toward the cut point to get them as similar as possible? Now, as we get closer and closer to the cut point, to get internal validity, what do we compromise on? External validity. Right? Because what we're talking about is if we got really good internal validity, we could say a lot about schools that were kind of close to the cut point. What we could say less about is the schools that were very far away from the cut point, either on the high side or the low side. So there were very clear trade-offs going there. So in a sense, you almost wouldn't just want to be at the cut point for external validity, but you'd love to be just at the cut point for internal validity. Does that make sense? So we were trading those things off, too. Yes?
I don't want to derail this, but I want to make sure I understand. So
you've got cut points for ratings that differ among themselves.
They differ across districts.
Right.
Different cut points, different kinds of ratings.
Ratings of different things.
There are schools in all cases, but ratings on different criteria. That's right.
And different criteria may be more or less susceptible to the impact.
It's not
Proficiencies. Like proficiency is one criterion that might have been used in one district.
To pick the schools. But that doesn't mean that that district was more or less susceptible to changing proficiency necessarily. There may be no relationship whatever.
So what I heard you say, and apparently I'm wrong, is that some of these arrays are percentage of kids or numbers of kids proficient.
Right. In the past.
In the past. And others are represent ranges of percent of children on free lunch.
Yes.
So you've got two qualitatively different criteria.
Ranking schemes, yes.
Ranking schemes.
Yes.
And so you're not concerned that the impact of reading first might play out differentially depending upon the criteria.
That is an external validity problem. I wouldn't say I didn't care about it. I always care about external validity, but we only have a modest amount of control over external validity. What we really want to say is that across a set of districts, relatively near their cut point, so the marginal schools that barely got in or barely almost got in, what was the impact of reading first? And in some ways, I mean, this will be a never-ending argument. In some ways, the fact that every district did it differently is a really good thing. A really good thing. Because what we're generalizing to more different kinds of things, more different kinds of situations. If they all went to schools that had exactly 40% proficient, let's say, which of course doesn't mean anything because proficient means different things for different percent. Let's just say, then the external validity of our study would be even more compromised because the kind of school we're talking about is the same across all those districts. But what we have is, for reasons beyond our control, we have different kinds of schools in different places, and we're taking an amalgam of those, and we're estimating impacts district by district, and then taking the average of those over the distribution of those. Okay, so it affects what we can generalize to, but it doesn't necessarily compromise our ability to estimate impact. And I just argued that it might even improve the external validity a bit in this odd way. Okay.
In a sense, would it be fair to say that you're doing multiple experiments? You have
multiple RDDs, yes. Yes.
So you can sort of aggregate them so they were...
We can do a meta-analysis.
Yeah.
You got the same outcome here.
Yeah, we don't have to do a meta-analysis, but we could. I mean, you can think of it that way. You can think of it as 18 studies, and then a meta-analysis of 18 studies. But we have all of the original data, so we can do it right from the ground up. That's right.
One of the reasons we're trying to get as close to the cutting point as possible is to mimic the tiebreaker range.
Yes.
And one of the reasons for not using the full range is, I think, considerably more Doug is getting at, is that you don't know what the functional form
That's
is.
what I want to get to.
Okay.
That's what I want to get to, exactly. That's what I want to get to. We were trying to be as independent a functional form assumption as possible, given all the constraints we were working on. Because if you're at the cut point, you don't have to worry about the function of this model, right? I just blithely put up straight lines, okay? Well, it doesn't necessarily follow that the relationship between the rating, whatever it is, and the outcome would be linear, absent the intervention. Doesn't necessarily. Now, that's one of the weaknesses of this design. Okay, that's the primary weakness with respect to internal validity of this design: is sensitivity to functional form. That's the primary weakness. And I could tell you. I mean, I need much more time. I could tell you about the various sensitivity tests and stuff we do about functional form, but that's the primary weakness of internal validity.
What is functional form?
I'm going to describe it. The idea here, the functional form of this picture is a straight line. It's a linear picture. But what if it were curvilinear? What if it went this way, or went that way, or it was an S-shaped curve, or whatever, in absence of treatment? So I haven't drawn these pictures, but you can draw a picture easily that's a curvilinear curve, and that if you fit it with straight lines, did a regression discontinuity, and there was no intervention at all, it would look like there was an effect. But it really was the curvature of the data and the linear specification of your analysis that were incompatible with each other that caused you to misestimate the impact. That's what I mean by sensitivity to functional form. Whether this is curved or not, straight, how curved, etc., you don't know that. You're back to modeling. You're back to, this is a quasi-experimental design. That part of it is non-experimental. The modeling part, right? I mean, the beauty of it is this cut point, that, in my mind. So that's why we're trying to get as close to the cut point as possible, because I still remember from my calculus class about 40 years ago that, as the interval gets infinitesimally small, everything's linear, right? Everything's linear. So that's the same idea, okay? You're trying to get closer and closer, compress that interval across the ratings. That interval of ratings gets smaller and smaller and smaller. You get it small enough, everything's linear to a reasonable degree, high order approximation. So that's the motivation for wanting to do that. The best, of course, is right on the cut point. The next best is damn close, etc., etc. Now you're out in a world where you better get the functional form right, or you could be completely wrong. So does that make sense? All right. So let's look at just a simple regression specification of a linear RDD model, a little regression that mimics this picture. Okay? A little regression that mimics this picture. Where Y is the outcome, that's the vertical axis. R is the rating, that's the horizontal axis, and you see beta 1 is the coefficient on R, that's the slope. And beta naught, T is a variable whether you're to the right of the cut point or to the left of the cut point, whether you're in the treatment group or you're in the comparison group. So the coefficient on T is what? It's the impact estimate. It's the displacement of that straight line. Now this is a very simple straight line. It says that the slope, the model says, you're in trouble. Oh no. The model says, that the slope of the line is the same on both sides of the cut point. That's the simplest specification of this analysis you can get. Okay? It says the only thing that happens is the intercept shifts. Right? You have a downward sloping line, the intercept is here, over here. It shifts up, that's the impact. The shift in the intercept is the size of the impact, right there. That's the impact. That's the impact. These are, this is a projection of that line across here. This is the counterfactual. In this design, the extension of this line over here is the counterfactual. It's the best estimate of what would have been the case in the absence of the intervention, right? This is what actually happened, and it's a line that goes through what actually happened. The distance between what actually happened and what was projected to happen as the counterfactual is the impact estimate. That's it. So it's very simple. Very simple. And a little regression like this gives you just that. Beta naught is the jump. It's the intercept shift. Beta 1 is the slope. Okay? Does that make sense?
What's the alpha?
The original intercept. Alpha is the original intercept. Hold on. It's this over here. And then alpha plus beta naught would be the second intercept. So beta naught is the shifting intercept.
It makes alpha go away if you just center on the cut point.
Right, which we did. Okay? Does that make sense? All right. So, very easy, but if it's really curvilinear and you estimate it as if it were linear, you could go dead wrong. But once again, the closer you get to the cut point, the less likely that is. Now, we can't eliminate that likelihood, but we can reduce how pronounced it might be by compressing the interval. All right. So now, what else? So, necessary assumptions. Well, I've jumped ahead. But the outcome by rating regression is continuous. The only discontinuity, that's only assumption, the only discontinuity is created by the intervention, regression discontinuity analysis. The regression is continuous. The discontinuity, the only discontinuity, is created by the intervention. That's the first. The cut point is determined independently of the ratings. We kind of said why, so the gaming wasn't going on. Ratings are determined independently of the cut point. That's the flip side of the same point. And then functional form of the outcome by rating regression is specified properly. That's what I've just been talking about. Those things need to be the case in order for you to have an internally valid impact estimate. Yes?
So it seems like the last assumption, the functional form of the outcome by rating regression specified properly, is dependent on how many units you have in a non-treated group. Am I right on that?
In both groups.
It's in both groups?
In both groups, yes.
So it's using the whole sample. And the functional form by outcome rating means essentially the slope of that
Yes.
straight line.
Yes.
And that if you go back 2 slides, kind of look at the equation. That equation. So that is the B1.
Yeah, that's the slope.
Okay.
Beta 1 is the slope. And notice the slope is assumed to be the same.
Okay.
Right?
Okay. Thank you.
You could estimate a different model, like we did. But your point is you need more data to estimate those more complicated models. More data points. You absolutely do.
Yes.
You absolutely do. All right. So now, this is the formula, although I realize it's a much simpler rendition of this formula. I didn't have time to change it. This tells you all about the relative statistical power of RDD, regression discontinuity design, and a randomizer study. Let me explain it. This is the variance of the estimate, the hat, of beta naught. It's the variance of the impact estimate. Beta naught is the impact, beta hat naught is the estimate of the impact. You with me? This is an expression for the variance of it, and you can derive this from lots of different places. It's a function of sigma squared, which is how much the points bounce around the line. Sigma squared is the variation of the points around the regression in the regression discontinuity. The more the points bounce around the line, the less you know. The less you know, the less precisely you estimate the impact. Okay? So sigma squared is in the denominator. That makes sense. The bigger sigma squared is, the more the points bounce around the line. The less you know, the less well you can estimate the impact. Right? All right. Now, R1 squared. There are 2 R squares here. You've got to keep it straight. You've got to keep it straight. R1 squared, R squared, explanatory power. Okay? R1 squared is the explanatory power of the rating. How much the rating explains the variation in the outcome across all points. You know, when you fit a line through points, you get an R squared. If all you did was fit the rating through those lines, it's a little more complicated than this, but if all you did was fit the rating through the lines, let's say for the experimental group by itself, there'd be an R squared. And that's how much reduction in the... Actually, the sigma square is not the sigma square around the line. The sigma square is how much the points vary from each other. Sorry. Let me go back.
That's the margin distribution.
Yeah. The sigma squared is how much these points bounce around from each other. Down and down. How much do they vary around the mean of those things? Okay? The R squared is how well this line explains those points, and how much of the variation from point to point is sort of captured by this line, which means that 1 minus R squared is how much residual variation there is around this line. 1 minus R squared is what proportion of the total variation in these points is left around that line, left to vary around that line. Does that make sense? Now, the better the line fits those data, the bigger R square is. The smaller 1 minus R square is. The less residual variation there is, the smaller the numerator of that term is. Sigma square is the total variation of the points from each other. R square sub 1 is the predictive value of that line with respect to those points. 1 minus R square is how much variation there is around the line. What proportion of the total variation to begin with is left after you fit that line through. So if you had a highly predictive line, if all those points were on the line, right? If all those points were on a straight line, okay, what would the numerator of that thing be? 0. Okay, you don't see that. That's not how it works. Something to aspire to, but you sure don't see that. Yeah, you could dream, but it ain't going to happen. All right, now the denominator, this is where the precision comes in. Well, there's some precision there on the R squared too. But here's where the precision loss comes in. How many people know about multiclinearity? All right, multiclinearity is the reason to lose the precision. And that's this R squared sub 2, okay, is in a sense, not in a sense, it is the correlation between T and R. You have a little regression with 1 dependent variable and 2 independent variables, right? T and R. Now, if T and R were independent of each other, if whether you were in a treatment group or the control group had absolutely nothing to do with your rating, like if you randomize them, really randomize them, there'd be no correlation between T and R, right? R2 squared is the correlation squared, in a sense, between T and R. All right? So an experiment, on average, in the long term, after we're all gone, gives you a correlation between the treatment variable and anything else equal to 0. Expected value of that correlation is 0. All right. But in an RDD, by construction, by design, you're picking schools based on the value of R. That's what it's all about. The whole design is premised on multicollinearity. Doesn't sound nearly as good that way, right? Doesn't sound nearly as good that way. But that's part of it. The whole design is premised on multicollinearity. The value of T is absolutely dependent on the value of R. That's the whole point. Okay? And that's R squared sub 2. The correlation between those two is R squared sub 2. Now watch. The bigger R squared sub 2 is, and it gets big, like about 0.75, you're left with 0.25. 1 minus 0.75 is 0.25, right? Now watch what's going on here. That's making the denominator smaller. You make the denominator smaller, what happens to the whole thing? It gets bigger. What is the whole thing? The variance of your estimator. Okay, so it's the multicollinearity that's killing you. Now, that T minus T squared, there's a much simpler way to talk about that. But the sum of T minus T bar squared is simply the total variation in treatment status. The zeros and the 1. It's the total, not variance, it's the total variation across all of your observations. Okay? Total variation. The more observations you have, the more total variation. The more variable they are from each other, the more variation you have. When you have 50-50, you have maximum variation in T for a given number of data points. So that's the total variation you have in the value of T, treatment control, treatment control, treatment control, across your sample. Now, to the extent, and that's the total variation. But what you care about is the independent variation. How much of that is independent of any other variables in the model? Okay, that's what you care about. And unfortunately, if 75% of the variance between T and R are correlated, that means only 25% of the variance, or 0.25 of the variance, is free of it. And it's only the free variation in T that is usable to estimate the effect of T on Y. Everything else that's confounded with R isn't usable. Okay? It's the free variation. Okay? And if only 25% of the variation in T is free, your sample is, a quarter the size of what you thought it was. Which means it has to start out 4 times as big. Okay? And that's exactly why we needed 240 or so rather than 2. Now, as an interesting footnote to that, a guy by the name of Arthur Goldberger, who's a very, very, very famous econometrician, first started looking into this some years after Don Campbell sorted it out. Put the idea on the table, and he proved mathematically that if, I forget, under certain conditions, that R squared would be 0.75. Okay, and I forget exactly what else. Part of it was a 50-50 treatment and control, and blah, 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 something like that. Something like that. So already 0.75 is where we expect it to be. That means you need 4 times the sample. But if it's not a 50-50, it actually plays out differently. And so we did some just for the hell of it, we did some empirical stuff. We just played with some numbers where we changed them around just to see what the correlation was in little simulations. And we always ended up needing under any kind of reasonable assumptions 3 to 5 times the sample with an RDD than we would have with a. I know the dependent variable has to be normally distributed for Goldberger's proof, and you have to have a 50-50 treatment control. Under those conditions, this works out. Okay, but the main point is that you need a much bigger sample for an RDD than you need for an experiment. So you got to be ready for that. Now we of course weren't ready for any of this. We had to change data collection plans, everything. Going from 60 schools to 240 schools, from 8 or 9 districts to many more districts, and everything had to change. But we were able to find, that's what I just said. We were able to find the 18 sites that gave us 250 some odd schools that we were pretty convinced we could argue did an RDD, met those conditions for an RDD, because once again, you can't know for sure whether cheating or gaming was going on. But to the best of our ability, we were pretty convinced that those sites played it straight. And then we had to recruit those sites and get them into the study. And the department had some control over them, so it wasn't normally the same kind of recruiting. They sort of had it. At some level, ultimately, they had to do it. And it took some more prodding for some than for others, but ultimately they had to because they were taking this money. And they had to participate in the national evaluation. And that's the sample we have now. We've collected some data. We're collecting more data. We are estimating it just like I said. I mean, it's a composite model, but it's basically estimating separate impacts for each site, and it's pooling those impacts in proportion, in our case, to the number of reading first schools in our sample in each site. So we're inferring statistically directly to the average reading first school in our sample. Then we have to tell a story about what does our sample mean, what might it represent. It's around the cut point in these places. The cut point means different things in different places. We'll never be able to say in less than 40 or 50 pages what population it is we're generalizing to, but that's often the case. But we will be able to display that there are a lot of these sites are very different from each other. It's certainly not a homogeneous group of sites, and that's. Oh well, I have a minute.
Compressed around this spider plot.
I know. I have a minute. I can do a minute. Okay. So one of the other exercises that we did, which became very important, that I'll talk about in a minute, in 1 minute, is sensitivity testing. When you do an RDV design, any of these cross-experimental designs, you got to really rely on sensitivity testing. So sensitivity to functional form is front and center. So you got to try to the extent it's possible. Now you're limited with the number of data points because it's not like 250 data points in one RDV. It's 8 data points in one district. It's 24 data points in another district. So it's pretty complicated. So what we did is we ran quadratics. We ran interaction terms where we let the slopes be different for the treatment and control, but we shifted the intercepts and the slopes. We ran where we could quadratics that shifted as you went across. We used non-parametric. We had to learn and then use non-parametric statistics. These things called kernel estimators and local linear regressions and stuff. There were so many things I'd never done before in this project. They're non-parametric curve fitting procedures, and usually they require far more density of data than we had, so we had to stretch these procedures. But to the extent that we could tell, we felt pretty good about these findings. Now, 30 seconds. The main test that we did, which we did before we had any follow-up data, which you should always do, is to try to ask the question, if I were to run an RDD analysis on the baseline characteristics of my sites, what impact estimate should I get if this thing is going to work? Zero. So we had baseline pretests on these schools, not the same kids. We had demographics. We had other kinds of things. We ran them separately, right through the RDD analysis, to see if we would get 0, 0, 0 again, negligible, 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 negligible. And we pretty much did. Now that begins to make you feel more comfortable using the linear specification. Then we tried it with other specifications and said, did it change those estimates appreciably, et cetera, et cetera, et cetera. So there's a whole lot more goes to it. But everything I've said is pretty much common sense, ultimately. There's a lot of sort of mathematical firepower around the edges, but the basic idea is the beauty of this is it's basically common sense. And so if it doesn't ring true to you in terms of your common sense, something's just wrong. Okay? And that's very helpful in any kind of design. It's all something.
That's it. We have tomorrow. We have a session set up to ask the questions. It's going to be at 9:30 to 10:30, and why at 1:44? And trying something new. A lot of times people come in and give us all this information and they go away, and we don't ever know what the dirty little secrets are underlying the analysis. Now, you've been very forthcoming in your dirty little secrets, and we appreciate that. But we know there are more. So rather than have a conversation now, give you a chance to think of the good questions, and we'll get them answered tomorrow. But we also have a chance to talk to Howard downstairs. Oh, up front. Where are we? We're up front. Yes. Some snacks and I don't know what else is out there, so everybody's going away. Anyway, thank you so much, Howard. It was just a fabulous time. Sorry for no, just be patient. Questions tomorrow.
I know.
I know, and then when I type it,
I got my first stats review from what works clearinghouse. It's a lot. And so I just started reading the million pages substantiation. So I just started reading all the million pages. And so I probably will have some. Yeah, and all the other. Yeah.
But they should only ask you to review one.
It was a report of a lot of interventions in different states that they only selected 2 as that qualified according to their standards, but I still have to read the ones that they didn't say qualified, right? And it's fine. And I haven't read it because it may not be as complicated as I think it may be, but if it is, then I'll probably need some third week. So, but you want to really try something. My deadline is November 20th, and so I
They just said that you was November 20th?
the actual report is 200 pages with the Tennessee concept.
But
you know, like,
the way that
the table set up, the deadline.